Bev, and thank you everyone else. So I am going to try and share my screen, and hopefully everybody is able to hear me okay. If somebody could maybe give me a nod or something, let me know that you're able to see my screen okay and able to hear me okay. That would be terrific. All right.
That's great.
Fantastic. So thanks so much for that kind introduction, and thanks to Zach and Michael and everybody, Sean, everybody at House Accelerator. You guys are doing such amazing work here, and thanks for the invitation to speak with you guys tonight. Super fun to be back, and nice to see everybody. Nice to see a lot of familiar faces here. Awesome to get a chance to talk with you guys. So I should just briefly. That's a great introduction. I'm actually no longer an architect. I got rid of my architecture license. I used to be a builder, no longer a builder. I used to be an architect, no longer an architect. I am mostly nowadays a passive house consultant, and I do a little bit of educating on the side, a little bit of teaching and instruction. As Bev said, I'm certified with both Passive House Institute and Passive House Institute US, so we work in both standards. And I have the privilege of teaching for all sorts of great groups like Passive House Canada, North American Passive House Network, or Passive House Network, New York Passive House, previously Passive House Academy when they were operational here in the States. And I've also worked for several different universities in the past, both Stevens Institute of Technology and Parsons, the New School here in Manhattan. So I'm based in New York, in the New York metro area. And as I said, super happy to be with you here tonight. So just super briefly, a little bit more about me so you know who the heck I am. As I've said, I'm a partner in the building performance consulting firm Building Type. We have a silly written name, but we pronounce it Building Type. As I said, we do mostly or almost exclusively Passive House certification to the FIAS and PHI standards. We come from an architecture background, so we focus mostly on the envelope side of the coin, on energy modeling, on construction phase consulting, detailing, working closely with the teams on communication. Time was that I spent a lot more of my day out in the field. I spent a lot more of my week with a hard hat on. Nowadays, most of my time is, like a lot of us on the call, I would imagine, sitting behind a computer. And in fact, probably 50% of my time nowadays is spent developing software tools as part of the Passive House Tools project, where I'm a developer and the maintainer in that project, building software tools, modeling tools to help Passive House designers do better, faster, quicker, cheaper. And so that's a whole other project we can talk about someday, but that's just a super quick introduction to the kind of things that we do. So when the folks from Passive House Accelerator asked me to be here tonight, they said that the theme for this month was air tightness, and so I said, "Oh, you know what we should do? We'll do a bit of a sort of overview of air tightness. We'll talk air tightness. It's a great topic, a super interesting topic." And what I thought would be interesting is if we share my top 10 list of ways to screw up your air tightness result. I don't mind sharing things we've screwed up. We've been doing this for a long time. We've screwed up a lot of things. And so I'm more than happy to share those. And maybe we can head off a few future failures. And of course, as we go through, I'd love to hear your thoughts. And if you want to share some of your failures as well, that would be awesome. Feel free to add those to the chat. So if you're new to Passive House, you might be thinking, air tightness in a building? That sounds like a weird idea. And yeah, it's a weird term. Whoever was in charge of branding that day maybe needs to go back to the drawing board. Air tightness is a weird word to use when we refer to buildings. It's kind of an unfortunate term, but we're stuck with it. Air tightness is an important piece of the puzzle when it comes to delivering Passive House buildings, and it's important for those of us on the design consulting side to educate our owners, builders, developers, architect colleagues on why airtightness is so valuable, so useful, so helpful, so important to our Passive House buildings. Now, why is it so important? Why are we going to spend a whole session here tonight talking about airtightness? Why is it such an important thing? Well, it is, of course, true that when we build airtight buildings, we use less energy. That's a good thing. It is also true that when we build airtight buildings, we improve the thermal comfort of the buildings, less draftiness, less humidity in the summertime. Those are a good thing. It's also true that when we build airtight, we're going to improve indoor air quality. That's definitely a good thing, improving the health of our occupants, less pollutants, less particulate matter, less allergens from the outdoors coming into our healthy buildings. Those are all good things. Those are not really the reason why we care so much about air tightness. Those are all important things. Those are all valuable things. We love those things. But the reason that we dwell on air tightness, that air tightness is so important, that it's such a fundamental tenet of passive house buildings, is because it goes directly to the question of durability. We want to make sure that in our high performance, healthy passive house buildings that we're designing and spending all this time and care designing and creating, we're never going to have a situation where we have warm, moist air coming in contact with a potential condensing surface, that warm, moist air riding on air currents as it moves through the envelope of our building. This is exactly what we're trying to avoid. And why do we care about it so much in passive houses? Well, in many cases, we've added a whole bunch of insulation, a whole bunch of fluffy stuff to the walls, roofs, floors of our buildings, and that fluffy stuff has done a real good job of retarding heat flow and slowing down the thermal energy as it moves through the assemblies of our building, and that can leave behind, in some cases, some cold surfaces. And those cold surfaces are at sometimes higher risk of mold, moisture damage in those buildings. So the reason we focus on air tightness is primarily around durability, though it does have all sorts of additional benefits as well. But it's absolutely crucial to building a healthy building for the long term. Now, of course, if you're certifying buildings, if you're designing buildings to certify to either the PHI-US or PHI standard, as I've noted, we work in both. Both of those certifications are going to have incredibly stringent air tightness requirements. So in addition to all the good things we get when we build an airtight building, we also have to build an airtight building if we want to try and certify our building to either the FIAS or PHI standards. Now, the specific limits are going to change and vary depending on the type of building, the size of the building, the type of certification that you're shooting for. There's all sorts of weird numbers that we can dive into at some point if you're interested about the exact limits for where those certifications lie. But more or less, they're all going to force us to build an extremely airtight, extremely durable over the long term building if we want to certify to one or the other of these protocols. Now, whatever protocol you're going to certify to, whatever certification standard you want to certify to within the different protocols, you're going to see in a passive house building very, very low levels of heat loss, very, very low levels of air infiltration and exfiltration. As I said, one of the benefits that we get from air tightness is that it significantly reduces our overall energy consumption, reduces heat loss in our buildings. This is just a graphic that I grabbed from a recent project of ours in our office. It's a townhouse retrofit that we're doing to the EnerFit certification. And I just grabbed this graphic out of the report, the assessment report that we produced a few weeks ago, just as an example. It's just an example of the kind of thing we see when we plot air tightness on the horizontal axis against heat loss on the vertical axis. And you can see here the rising heat loss as we move to the right on the horizontal axis as the building becomes leakier, as the air tightness becomes worse. So no matter what passive house standard you're certifying to, no matter what certification level within the standard you're certifying to, you're going to be way over on the bottom left-hand corner of this graph. So we have to build very airtight buildings. We have to achieve very high level of air tightness. Okay, so we care about air tightness. It's super important. We've got to focus on it because it's the right thing to do, but also because we want to certify our buildings. However, there are 1,000,001 ways that we can fail to actually achieve our air tightness goals. Now, I'm going to focus on 10 failure types that I've observed in the field, that I've seen in my own work and in our own colleagues' work over the last dozen or so years that we've been designing and building these passive house buildings. But of course, there are many more. And as I said, I hope you'll volunteer yours to the chat here this evening as well. So there's lots of different ways that we can screw it up. There's lots of different ways that we can fail. I have 10 in no particular order, but I would like to sort of offer maybe 3 different categories, maybe 3 different ways that we can kind of categorize our failures. So I think we can sort of say that in general, we have a category of failures that we can call planning failures. These are failures that happen for those of us with pencils in our hands, computers at our fingertips in the planning phase. There's another class of failures, a different type of failures that happen in the implementation phase. All the best planning in the world, if it's not implemented correctly, results in a special class of failures. And then there's another set of failures that happens on the tail end around the testing of our buildings. So there's another type of failure, another class of failures that we see when it comes to airtightness around the testing side. More or less, that's not testing enough. But we'll get to those, of course. So let's kick it off. Here are my top 10 list of ways to screw up your airtightness of your building in no particular order. Let's start with the planning failures. The number one way to screw up your airtightness, not knowing where your air barrier is, not having properly thought about what the air barrier of your building is. On any passive house building, there should be one continuous airtight layer, and you should be able to execute what we call the red line test. Now, the red line test is best done on a piece of paper. It's not best done in the computer. I know we're all on the computer all day. Do this on a piece of paper. Print out a plan, print out a section of your building, go down to the local CVS or Rite Aid, get yourself a big fat red marker. Take that big fat red marker, start in one corner of the building, and trace the airtight layer of the building. And if you ever come to a scenario, a spot where you're confused or you're uncertain about how the airtightness is going to transition, how it's going to connect different layers, you put a big red circle. And then you come back and you detail it properly. As I said, there should be one continuous airtight layer with no breaks or gaps. And it should be very obvious. You should know exactly where the airtight layer is in all of your assemblies. Of course, our assemblies are very complicated. We have lots of different materials and layers in them, but you should know which one is the airtight layer. There should be no ambiguity or confusion about that. Now, you can have more than one. You should have one, but you could have more than one airtight layer, especially if you're doing something like compartmentalization in multifamily buildings, right? So many larger buildings, we want to compartmentalize, make sure that if one person is in an apartment is cooking fish or smoking, that doesn't get into another person's apartment. So you might have interior airtight layers as well. That's great. That's all well and good, but there should be at least one continuous airtight layer around the entire conditioned space of the building. Now, number two on my list of ways to screw up your airtightness is not knowing how the pieces of your building are all going to connect together, more or less not detailing your building well enough. I have observed, and I think I'm probably safe to say, that in North America, in the United States at least, where I operate, coming from a very United States perspective here, admittedly, in the United States at the residential level, many architects, developers, builders have more or less over the last 20, 30 years outsourced the detailing of their residential buildings to the product suppliers, to the manufacturers. You go to the window supplier and you ask them, what is the install detail for your window supposed to look like? For passive house buildings, that doesn't really fly. For passive house buildings, we have to have enough documentation and enough resolution in the planning phase to know exactly how all the pieces are going to fit together. And if you don't know, if when you're looking over one of your details, you're confused, if you're scratching your head about where the airtight layer is, how it's going to connect, and you're confused sitting in your air-conditioned office in your cushy seat, I can guarantee you that the guy up on a ladder in the rain, in the snow, will also be confused. So resolve this during the planning stage. You should know exactly where the airtight layer is. You should know exactly how it's going to transition, what products are being used, and how that airtight layer is going to move around the entire conditioned envelope of your building. The other piece that I'll add to that is when you're doing this type of detailing, you need to be thinking about sequencing. We need to be thinking about first this and then that. First, I'll do this layer and then I'll have the additional layer. When it comes to airtightness, a lot of it is about sequencing and a lot of it is about how the different pieces come together over time. This is just one example of a detail. I saw Tim Spittler's on the call here this evening from R. Sutton. This is a project that we're doing with them in Manhattan. Those guys are doing an amazing job on a really nice backstayingway multifamily building. This is a beam pocket detail. And as you can see here, they've done a great job of prepping the rough opening with an air tightness layer. That's the sort of white liquid applied material that you can see there, and before installing the sort of structural steel on the building, right? So really good thinking ahead, really good sequencing, good planning on a project like this. And my number 3 way to screw up your airtightness in the planning stage is to specify or plan to use materials that don't belong together, that don't play nicely with one another. Not all materials stick to all other materials. These photos are from actual projects of ours. The project on the left there, a commercial multifamily project. Clearly, that flashing material is not adhering to that roofing material. On the right-hand side there, that's an amazing project built by an amazing builder. But what do you see? You see, I don't know, what, 15 different products there. We've got some zip tape and some ice and water and some zip and some, I don't know, 3 different tapes being used there. We've got a subgrade waterproofing on the foundation there. There's a tremendous amount of complexity going on there. Are you sure that all of these things stick to one another? Maybe they do, maybe they don't. You need to really think about these things when you're in the planning stage. Make sure that you're specifying the correct products. Now, I've heard Kevin Brennan say several times, and I 100% agree with this, just choose a product family and stay within that product family. I couldn't agree with that more. I don't care which product family you want to go with. Use whatever manufacturer tickles your fancy, but stick within them. Don't try and take a tape from this guy and a membrane from that guy and a roofing from that guy and sort of weave them together yourself, unless you're prepared to actually do the compatibility testing and the adhesion testing. Right? That's fine. You can do that if you're willing to actually do that extra work. So we've got a bunch of planning phase failures there. Absolutely. That's a good way to screw up our building, is to improperly plan. But there's plenty of other ways to screw up our building. As I said, we have a whole other class of failures on the build side, on the execution side. So my 4th way to screw up the airtightness on your project is to not communicate correctly to the installers what the heck it is they're supposed to be installing. You could maybe say this a little differently: having installers who don't have enough education in the specific tools, techniques, and needs of passive house buildings. So this is maybe a hybrid. This is maybe a bridge. This is both a planning failure and an implementation failure. So there's lack of education on one side and lack of communication on another side. Now, what you see in the photos here is the opposite. This is actually an attempt to overcome that. This is a few photos from a window installation mock-up. It's a project of ours from several years ago. You see a whole bunch of design personnel as well as a whole bunch of implementation personnel. We've got all sorts of folks from all sorts of different disciplines all together on the site, all focused on the question: how are we going to install these windows? How are we going to air seal these windows? How are we going to flash these windows? And we're working through it together on the actual job site with the actual guys who are gonna do the actual installation. You see the guys on the right-hand side there working through some of the taping, and we're working together to resolve issues or challenges that they perceive and come up with good solutions. Right? So this is an attempt to overcome these issues of not communicating well enough. There's a sort of a part B to this method, though, which is that even if you do a bunch of really careful work educating part of the team, especially when it comes to larger commercial projects, there is a strong likelihood that at some point those well-educated team members are probably going to go off to another job somewhere, and you're going to get the B team show up on your job, and then you're going to show up on a job site. You're going to see things like this, and you're going to say to the installer, "What the hell happened here? What's going on?" And the installer is going to say to you, some 19-year-old kid is going to say, "Eric told me to come over here and put some tape on the windows." Well, I spent 3 days with Eric talking about exactly how we were supposed to put the tape on and how you're supposed to apply it and some of the different conditions. You know, these things, these are the challenges that we run into when it comes to these types of commercial projects in particular, right? These are huge hurdles that we've seen on lots of different projects in lots of different places. This is not relegated only to airtightness. This kind of cuts across all commercial contractors for sure. So definitely a challenge. Definitely a good way to screw up your building is screw up your airtightness is to really, really educate part of the company that's doing some of the installation. Now, another type of build failure that we've observed, my 5th way to screw up your airtightness, is to just carry on with business as usual. To just keep doing what you do, and then maybe layer on some of that passive house business as a sort of, also we should maybe do that. We'll like fold that in somewhere after we do all of what we're doing. What are you seeing in the photo here? What you're seeing in the photo here is one of our earliest passive house buildings. This is from, I don't even know, 2010, maybe 2009. And what happened here was that you see there's an air tightness membrane on the roof or on the ceiling. And the framing contractor didn't want to hear anything about it. He didn't want to change how they were doing their framing, didn't care about any of this business. And we were quite green and weren't prepared to force the issue. And they said, listen, we're just going to frame the building the way we frame the building. You guys can come in and put your air tightness membrane. And whenever we're done, when we're on to the next building, you go ahead and tape around all those interior partitions. Well, all right. I mean, we're going to use like twice as much tape, and it's going to take us like twice as long. And it turns out we're going to do twice as bad of a job. This type of detail here, where the air tightness is not continuous behind those partition walls, behind, in this case, the top plate of the wall, these are areas where we commonly see leaks, no matter how much tape, no matter how much attention you're going to put to that detail here. On the left hand side, you can see an infrared image of air leakage during a blower door test. So the colors there representing different temperatures of air. You can see cold air leaking into the building under a depressurization blower door test. Clear evidence of failure of this detail. And largely, this was because we didn't come up with a good detail that was something that the builder felt like they could actually execute. And they insisted on having us come in and do air tightness as a second layer. And that doesn't work. That's not going to work. Now, the sixth way to screw up the air tightness on your beautiful passive house building, this is an easy one, have doors in your passive house building. You know, the reality is 2022, in a modern passive house building, these types of buildings are really best appreciated from outside, looking at them from the outside, or from sitting inside with everything sealed up. This business about moving from the inside to the outside, you know, that's not going to cut it on these passive house buildings. Now, in all seriousness, though, doors are the place where we see the most significant failures. Windows, for the most part, folks have a pretty good beat on this point. Most windows are actually pretty decent when it comes to air tightness and reducing air leakage, but doors are a constant disaster. Every door we've ever installed, every door I've ever assessed, every door we've ever looked at has problems, has issues, has failures. And the biggest failures are almost always at the sill. Again, we see some infrared images here. The different colors corresponding to different temperatures. And you can see here, these are both images taken during depressurization tests. You have outdoor cold air coming into the building. You see the cold air leaking in under the sill of these doors. It's very common in a lot of buildings that we see. Now, that's a problem on small doors. It's an even bigger problem when the doors get silly. This is a fully certified PHI building with essentially walls of glass. I don't even know that you would really call these doors. I don't know what you would call these. Beautiful building, amazing design, lovely place, very challenging from an air tightness perspective. Those doors, giant walls of glass that move around, they're incredible. They're beautiful. They're amazing. They're incredibly low U value. They're really, really great from a thermal control perspective. They're very, very hard to install properly. Read the specification. It says that's a 4 meter long door. You want that to be level plus or minus a millimeter. Oh, do you? Oh, well. Those types of installations are incredibly challenging, especially when we're talking about commercial construction. Right? That's a lot to ask for that door to be installed basically perfect. And then, of course, we see the biggest issue on these doors, even doors that have been installed more or less perfectly, more or less impeccably. We still see leakage at that middle rail, that check rail, the meeting rail there. You know, the reality is those bypass gaskets are very hard to make airtight. It's very hard to get those to actually seat properly. So at that middle check rail on those lift and slide doors, there's almost always going to be some residual air leakage, even in doors that have been installed absolutely perfectly. These doors here, this is from one of the best contractors we've ever worked with. These guys did an amazing job. But even then, these doors are not perfect. You're going to see some air leakage at these doors. Got to plan for that. Assume you're going to see some air leakage there. What else do you see in this infrared image on the right-hand side there? Again, you're seeing temperature. Notice the temperature scale on the right-hand side goes all the way up to 92. How is that possible? Well, in many of our projects recently, what we've been doing, and maybe if you don't want to hear this, plug your ears, we've actually been installing a little bit of radiant heating right at those doors because we know that there's going to be some challenges around drafts and durability, condensation, and the like. So we've been installing maybe a foot, 300 millimeters of radiant, electric radiant right at those doors. That's a very common trick that we use in some of these projects. Only runs a few hours a year, but it gives the homeowner at least a button to press or a lever to pull if they are seeing some issues. And my number 7 method for screwing up your air tightness is to not use a service cavity. Right? Service cavities are a great way to keep electric and plumbing from penetrating your airtight layer. Is it possible to install the plumbing and electric in your air tightness layer and have it penetrate through? Yeah, you could tape the hell out of things. You could invest in a couple hundred rolls of dollars worth of tape per receptacle. You're still not going to get a very good result. You're going to see a bunch of leakage through those. The best thing you could do is just move all of that inboard of the air tightness layer, use a service cavity. I know it's a few extra inches, but it's absolutely going to make your life a lot better. And it's going to work great protecting that airtight layer. My number 8 technique for ruining your air tightness score, not paying enough attention to mechanicals. We often detail the heck out of the envelope connections, the window connections. We're going to work really hard and pay attention to things like doors. And then I will admit, I'm not a mechanical guy. I often lose sight of the mechanicals. Especially on big, complicated commercial buildings, you're going to have more mechanicals than you could ever possibly imagine running every which way around your building. And they're going to be moving through basically every surface on your building. You need to pay attention to those penetrations. You need to think about those penetrations, plan for those penetrations, make sure to educate those installers, and then go back into your quality control, make sure that you seal up those penetrations after the fact. So don't forget about mechanicals. They're really important. And especially on big buildings, commercial buildings, those mechanical penetrations are going to be some of the largest areas of air leakage on your project. Now, my last 2 methods for screwing up your building or screwing up your air tightness have to do with testing failures. So there's essentially 2 different ways that you can screw up the testing, and they both more or less are don't test enough. So first of all, my number 9 method for screwing up the air tightness on your building, don't do enough blower door testing. Blower door testing, it's not that fancy. Take a blower, a fan, you put it in the door. Thus the term, blower door testing. You put some plastic around it. Then you run the fan to depressurize or pressurize the building, and then you can find and identify and fix the leakages through the envelope and the penetrations and the windows and the doors, all the areas of your building that are having issues. You should do many, many blower door tests. We've done as many as 12 blower door tests on a single project. You probably don't need to do 12, but you should do lots and lots of blower door tests. Don't be afraid of this machine. This machine is not magic. Everyone should have one of these machines. If you don't have one of these machines, just buy yourself a fan and 30 cents worth of plastic and plastic off a door and put the fan in the door and then run it. You'll still be able to feel those air leaks on the back of your hand. Maybe you don't have a fancy computer hooked up to it, but who cares? You can still identify and find those air leakage points. You should do this early and often. You should execute this blower door many, many times, this blower door test many, many times during construction. And my last way to screw up your air tightness, the air tightness on your building, is just to not use all of the amazing technology that we have available to us now. Talked a little bit about infrared imaging. Now, time was an infrared camera would set you back maybe $5,000, $10,000, right? Nowadays, that is not true. You can pick up a really nice, useful infrared camera, a durable infrared camera for a few $100s at this point. And if you, like me, style yourself a professional, you do this for a job, this is what you do for a living, I believe you should have the tools to do your job properly. So invest in yourself and your company and your tools. Make sure that you have the right tools for the job. It's not a big lift to get yourself a simple infrared camera. It's an amazing piece of technology. Again, allows us to more or less see the temperature of the things around us, right? So get your hands on the right technology and use that technology to do your job properly, do your job better when it comes to designing and implementing and constructing these passive house buildings. Now, of course, we don't have to use fancy technologies, though. There's a sort of a 10B. There are, in fact, some pretty simple tools that all of us have that we can use on our projects. One of my favorite tools that I deploy on projects is just my eyeballs. When I walk around and I see something like this, I don't need a blower door test. I don't need a smoke stick. I don't need a fog test. I don't need an infrared camera. All I need are my eyeballs in my brain to be able to say, hey guys, there's a 4-inch gap. And also, that tape doesn't look like it's actually adhering to that masonry. Right? Just takes a little bit of paying attention, a little bit of thinking, a little bit of eyeballs. The other thing I would say, the last thing I would say when it comes to this is don't be afraid to break stuff on the job site. The other tool that I like to use in order to assess airtightness are my fingers, my puny human fingers. If I, with my puny human fingers, can go through and ruin some of your airtightness detailing, if I can rip that tape off, if I can scratch that liquid applied membrane off, if I can damage your airtightness implementation with my pathetic human fingers, well, it was never really done very well in the first place then, was it? I should not be able to delaminate or pull that tape off if it's been installed properly. Right? So go through, tug on things, pull on things, try and break things when you're on those job sites and see if they hold up. So that is Ed's top 10 list of ways to ruin your blower door test. And number one, not knowing where the air, which layer is the air barrier, not knowing how the pieces are supposed to connect together, using products that don't actually stick together, not telling the installers what the heck they're supposed to be installing. Part B, losing your well-educated installers to another job, carrying on with business as usual, having doors to your passive house building, not using a service cavity, not paying enough attention to mechanicals, not doing enough blower door tests, and not having or purchasing or buying or investing in the right tools to do your job properly. If you overcome all of those, if you flip all those around and you succeed, you overcome all of those, in that case, I think that you will, as we have on many projects, succeed in achieving a very airtight building. You should hopefully be able to build a building which is going to be comfortable, healthy, durable for the long haul. So I will leave it there. I have droned on for a long time. I was supposed to go on for 15 minutes. I apologize. I was hoping it would be faster than that, but it wasn't. So I'm sorry about that. I will close there.